This video will focus on mechanisms, a key topic in paper 2, and this is the basis of organic chemistry. So just to summarize for you, I do have another video on my channel on mechanisms, but the mechanisms we're looking at is free radical substitution, and that occurs when alkanes react with a halogen-like chlorine in the presence of UV light. Then you've got electrophilic addition, and that is alkenes reacting with something like HX, and the double bond can break and things can add across it. Got nucleophilic substitution, I'll just call it nucleophilic sub. This is where you have a polar carbon halogen bond and a nucleophile can attack that. You have elimination, and there are two elimination reactions, halogenos and alcohols. In both cases, you lose a small molecule, a water in the case of alcohols, and a water or NaCl or something like that for halogenos. In both cases, the product of elimination are alkenes. Then at year 13, we do nucleophilic addition, and this is aldehydes and ketones because you have a very polar carbonyl group. We do electrophilic substitution, which is benzene ring, which needs an electrophile, and then we have addition, elimination, nucleophilic addition, elimination, acyl chlorides because they have two very polar groups. This is a summary of the mechanisms you need to be aware of. What I will focus here is specifically I'm going to focus on the exam questions in front of us, and through this I'm hoping that I can get most of the mechanisms done here. So let's start with the first one. You've got amine. Amines are nucleophiles because a nucleophile is a electron pair donor. So donates a pair of electrons or shares a pair of electrons to a delta plus carbon. So what happens here? You've got acyl chloride. So we're going to get an addition elimination mechanism here. So the CO, now I do like putting dipoles on. I'm going to enlarge this. So the carbon is delta plus, oxygen is delta minus, because oxygen is more electronegative than chlorine. So the first arrow is going to go towards oxygen, and the lone pair on the nitrogen is going to go towards the carbon. A curly arrow means movement of pair of electrons. What do we get? Well, we just concentrate on the functional group, and because the oxygen drew a pair of electrons towards itself, it became negative and a pair of electrons. And then the nitrogen, look, because the nitrogen has the lone pair, it attacks the carbon. So it's the nitrogen that directly attaches to the carbon, and the nitrogen has two hydrogens, and then the rest of the molecule is irrelevant. Now that first part is addition and the second part is elimination, because what's going to happen now is the CCl bond is going to break, so we show an arrow for that. The NH bond breaks like that, and the lone pair on the oxygen goes back in, and you form the product. So there's 2 marks here and there are 2 marks here. So nice easy mechanism, you will definitely get that. So that's nucleophilic addition elimination. You're also going to get some unusual type of of mechanism which seems as if you haven't seen them, but they will not ask you mechanisms outside what we've already covered. Okay, so here the question says that involved in 3 steps mechanism for the reaction. So it's saying complete figure 2 by adding curly arrows and relevant lone pairs of electrons in these steps. So let's see, how do we work this out? Well, if you look here, let's look at the change. Oh, this CO gains an OH, and can you see the water has become O minus, which means that this must happen because oxygen's gained O minus, hasn't it? And remember, this oxygen will also have a lone pair on it, which we will do here in this step. Okay, and what will happen now is, see this oxygen, it has a lone pair because it's a nucleophile, it attracts this hydrogen. That's why you've got this setup here. Okay, then in the next step, the carbon is positive here, and if you look at step 3, carbon gains another OH here, so the lone pair on this OH minus must attack that. So this is like a nucleophile attacking. Okay, it's a nucleophile attacking, and uh, that's the only arrow, isn't it? And then you get your product to make. So this is an application type question. Let's go to propanone reacts with bromine in alkaline conditions, and complete the mechanism in the figure by adding 4 curly arrows and any relevant lone pairs. So it's not your traditional mechanism, is it? However, note, let's look at step 1, look at the changes. Here's a change, which means this nucleophilic reaction is happening. This is like nucleophilic reaction. Here, that's acting as a base, and you've seen that in the elimination reaction. So can you see here elimination is also happening? So the base is there. And how does a lone pair, or how does a double bond form here? Well, the CH bond goes back in like that. So this is this part here, this part here is elimination part. Then let's go to mark 3. Can you now see this is electrophilic addition part, because the double bond is electron rich, shares a pair of electrons with bromine, which becomes electron deficient because the other bromine is polarized. So that is actually what is happening in these mechanisms, and those are your arrows. And one more arrow, easy to miss, carbonyl reforms. That means the lone pair on the oxygen here goes back in there. Question does say 4 arrows, and there are your four arrows there. Okay, so just got to be on the ball there. Okay, this question is about intermediates in reaction mechanisms, and figure 1 shows an intermediate formed in the first step of a nucleophilic addition elimination reaction. So here's what you need to know. For addition elimination, you need you need acyl chloride there. So you got CH3, there's your acyl chloride. You need a nucleophile, and your nucleophile here is your methanol. So the methanol, let's draw it as they've drawn it. Lone pair attacks the carbon there, and the C double bond O breaks there. Okay, You see what's happening there? Then I'm putting the arrow there, that forms, and then the CCl bond breaks, the lone pair on the oxygen goes back in, and then the OH bond breaks there. So this is step 1, addition, and this is elimination. So that's twice we've done that. Next one is nucleophilic substitution reaction. How did that happen? Okay, so what you had methyl benzene. Methyl benzene reacts with the electrophile nitration. Make sure you put the positive on the nitrogen, and the ring attracts that to give you, and then the CH bond breaks in there. So make sure you know the catalyst here of that. So we've actually done most of the mechanisms here. And the next mechanism, which I think is crucial, is this one. Now this is nucleophilic addition elimination, because as you know, aldehydes and ketones can react with HCN or HCl stroke KCN, or with NABH4. So this is coming from NABH4. So again, this is nucleophilic addition. The CO bond, there's delta plus, there's delta minus, and the lone pair on the nucleophile attacks the delta plus carbon. When you do that, you get that, okay, and then that will attract H plus here, which comes from water, and your final product will be an alcohol. They haven't asked you for the full of it, but that's the end product here, and that's nucleophilic addition mechanism. So we've done electrophilic substitution, we've done nucleophilic addition, we've done nucleophilic addition elimination, and we've actually done electrophilic addition, and we've actually done elimination. So and we've so actually we've done all the mechanisms except for the 2 left, which is now 3 left: nucleophilic substitution of halogenos, elimination of alcohols, and free radical substitution of, and that will come somewhere else. Now this question is about ethanoic anhydride, incomplete mechanism. See what's happened here. There's a breakage that happens here. The reason I know this is you got CH3CO on this side, which means that what must be happening is that this CO bond must break there. And then if a double bond forms in step 2, that means that this is a double bond, and see this lone pair on the oxide here, that attracts that hydrogen, and that's the product you're getting. And that's another good example of another mechanism that's going on there. Now this is very common in AQA now. They're giving you bits of the mechanisms which you really do need to know. So here, this is addition. So this one is like nucleophilic addition elimination. And what happens now is the lone pair on the nitrogen. Now this is acting as a base now because it's accepting that hydrogen there. So that's what's happening there. So that HN bond must break to give you the product there. Okay. So, and another example of a nucleophilic addition elimination mechanism, because the oxygen has taken a pair of electrons towards itself, and then that's what you've got, and then this is nucleophilic addition. We normally do this in 1 step, but here they've done it in 2 steps. A nice cyclohexene, the double bond attracts the bromine. You get an intermediate here of Br and plus, and then the bromide attacks the plus of nucleophilic, of electrophilic addition. Now, what about halogenoalkanes? CCl bond breaks, ammonia attacks the carbon, you get CH3, CH2, NH3, and then excess ammonia acts as a base here. It's a nucleophile here and a base there, and then that bond breaks. That's pretty much all the mechanisms you need to know. Been through a few questions with you here. There isn't a lot of explanation. However, some of the key things I do need you to understand is, firstly, the reason why alkenes and benzene undergo electrophilic reactions is because they both electron rich. The double bond is electron rich. So electron rich species attract electron deficient species. The reason why halogenoalkanes and aldehydes ketones or acyl chlorides undergo nucleophilic substitution is because the more electronegative element attracts electrons towards itself, leaving a delta plus carbon. And a nucleophile, which could be hydroxide, which could be cyanide, which could be an amine, will attack the delta plus carbon. And why do alkanes undergo free radical substitution? And let's do an example of it. Okay, plus chlorine, and we want to form two bromo, two chlorobutane. Okay, so what are the steps? Well, you've got your initiation step, and then let's look at your propagation step. Now, the arrow is very important here, and please do not do this mechanism in terms of molecular formula. It's got to be structural formula. CH3, CH2, the second carbon loses its hydrogen to form HCl. And then in the second propagation step, chlorine attacks and you get CH3, CH2, CH, Cl, and Cl dot. And that really is for mechanisms. I'll do another video on, next video I'll do is on organic synthesis. I do want to do one on NMR and one on rates, and then I'll do anything else on organic chemistry I need to. So